Welcome. This is the second video of the lesson The Solid State. This course is for 12th standard chemistry. This is brought to you by secondpuctuition.com. It is a part of IES. This video is presented by Aditya Krishna. You can reach me at agk@2puctuition.com. Crystalline solids have a sharp melting point. On the other hand, amorphous solids soften over a range of temperature and can be molded and blown into various shapes. On heating, they become crystalline at some temperature. Some glass objects from ancient civilizations are found to become milky in appearance because of some crystallization. Like liquids, amorphous solids have a tendency to flow, though very slowly. Therefore, sometimes these are called pseudo-solids or supercooled liquids. Glass panes fixed to windows of old buildings are invariably found to be slightly thicker at the bottom than at the top. This is because the glass flows down very slowly and makes the bottom portion slightly thicker. Crystalline solids are anisotropic in nature, that is, some of their physical properties like electrical resistance or refractive index show different values when measured along different directions in the same crystals. This arises from different arrangements of particles in different directions. This is illustrated in the figure shown. Since the arrangement of particles is different along different directions, the value of the same physical property is found to be different along each direction. Amorphous solids, on the other hand, are isotropic in nature. It is because there is no long-range order in them and the arrangement is irregular along all directions. Therefore, value of any physical property would be same along any direction. There is a table that you can find on the website, and that table summarizes the distinction between crystalline and amorphous solids. Please do go on the website and check it. Classification of crystalline solids. We have learnt about amorphous substances and that they have only short range order. However, most of the solid substances are crystalline in nature. For example, all the metallic elements like iron, copper, and silver, non-metallic elements like sulfur, phosphorus, and iodine, and compounds like sodium chloride, zinc sulfide, and naphthalene form crystalline solids. Crystalline solids can be classified on the basis of the nature of intermolecular forces operating in them into four categories, namely molecular, ionic, metallic, and covalent solids. Let us now learn about each of these categories. Molecules are the constituent particles of the molecular solids. These are further subdivided into the following categories: nonpolar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. Nonpolar molecular solids, they comprise of either atoms, for example as in argon and helium, or the molecules formed by nonpolar covalent bonds, for example as in hydrogen, chlorine, and iodine. In these solids, the atoms or molecules are held by weak dispersion forces or London forces, about which we have already learnt in class 11. These solids are soft and are non-conductors of electricity. They have low melting points and are usually liquid or gaseous in their state at room temperature and pressure. Polar molecular solids. The molecules of substances like HCl, SO2, etc. are formed by polar covalent bonds. The molecules in such solids are held together by relatively stronger dipole-dipole interactions. These solids are soft and non-conductors of electricity. Their melting points are higher than those of non-polar molecular solids, yet most of these are gases or liquids under room temperature and pressure. Solid SO2 and solid NH3 are some examples of such solids. The molecules of such solids contain polar covalent bonds between hydrogen and fluorine, oxygen, or nitrogen atoms. Strong hydrogen bonding binds molecules of such solids like water in the form of ice. They are non-conductors of electricity. Generally, they are volatile liquids or soft solids under room temperature and pressure. Coming to ionic solids, ions are the constituent particles of ionic solids. Such solids are formed by the three-dimensional arrangements of cations and anions bound by strong Coulombic forces. Coulombic forces are electrostatic in nature. These solids are hard and brittle in nature. They have high melting and boiling points. Since the ions are not free to move about, they are electrical insulators in the solid state. However, in the molten state or when dissolved in water, the ions become free to move about and they conduct electricity. Thanks for watching this video. The lesson will be continued in the next video.